Okay, welcome everyone, and good morning, good evening, and good afternoon, wherever you may be. I'd like to welcome everyone and thank you so much for joining us this morning for Campfire Restoration Project's Green and Fire Resilient Building webinar. The Campfire Restoration Project, I'd like to say, is based on the lands of the Mechoopda Maidu, the original tenders of this land, and we want to acknowledge that and acknowledge that the Mechoopda people continue to live here, have relationship with and sustain this land, and have done so since time immemorial. My name is Stacy Ware, and I'm the current chair on the board of directors for this nonprofit that we call the Campfire Restoration Project. I'm actually zooming in today from the very rainy Miwok territory in southern El Dorado County in my little trailer, as you can see behind me. And like I said earlier, for those who may have just joined us, we'd love to know where you currently are. If you want to put that in the chat, we really like to know that. Just a little introduction for those who may not be familiar with our work at CFRP. We're a land and community-based restoration group based in Butte County in Northern California, who began meeting immediately following 2018's campfire. Our formal goals as an organization are to promote ecological stewardship through education, collaborative community action, and resource sharing. And we also like to have fun, on occasion. We are, as of this year, a legal 501c3 nonprofit, and we're currently funded through donations and grant monies, such as North Valley Community Foundation's Butte Strong Fund. So big thank you to them. And again, a big thank you to all of you for being here. I'd like to introduce and thank our host for today, Wayne Hill. And Wayne's lovely wife, Kathy, is our Zoom tech for today. I'll be our timekeeper. So if you're getting really impassioned and just going on and on, I'm going to butt in and just tap you on the shoulder and just give you a little warning that you have a few minutes left. But we're going to be pretty flexible. We hope to have time for questions after. So Wayne has brought us all together today, and I'm excited to see what comes out of this. Wayne, our host, is one of those people who has a lot of interests, many interests, and he's so capable in a lot of different directions. But today, what's sticking out for me is his proclivity for building things and creating houses, infrastructure, musical instruments. I mean, I saw him put together a plastic tube music instrument, and it sounded great for a camping trip. He's a builder, he's a creator, which makes him the perfect host for this webinar. Wayne was formerly on the board of CFRP, and he has since become one of our most active volunteers. We're super grateful for him. Take it away, Wayne. Can't hear you, Wayne. We're having some mute issues.
Yeah, everyone got muted. We have to unmute. So this is our third webinar in our 4-part series. We started with soil and fire. We did water and fire. This workshop on green building and fire resistant building. And the last webinar will be on May 12th, seeds and fire from 2 to 4. So our underlying theme is fire through all of our webinars. Today, we're going to talk about green building, and by that we are describing sustainable building, energy efficient building, reduced waste, and fire resistance, which is really important in our area and other areas of the world where we are seeing increasing fire danger. So our format today will be 15 minutes for each presenter. And if you have any questions, feel free to enter them in the chat, or just wait until all 3 presenters are done, and then we'll have a question period. And when that starts, you can either raise your hand or use the hand icon button, and you'll be recognized, and you can unmute to ask your question. And if you're having any technical difficulties, message Kathleen Mowdy, our facilitator, in the chat. So we are ready to begin. Mike will be our first presenter, and we'll be speaking today about Strawbale. Thank you, Mike.
Well, good morning, everybody. My name is Mike Deveria. I'm originally from Scotland, but my wife is Dutch, so I've lived in Holland for over half my life. The background to how I got into this, just to be very quick, I don't know if you've heard of ecosystem restoration camps. They started in Holland by a guy called John Dennis Liu, and he was filming the restoration of the Loess Plateau in China. He is half Chinese, half American, and he took it on himself to regenerate the world. We have 56 camps around the world, of which 6 are in California. And it was last year when I was in California visiting my son, who lives in San Jose, that we visited 4 of these camps, one in Coyote, and then Jonathan Cabat up in Hotlam, Matthew Trum in Oroville, and Geneva Sorensen in Paradise, where we met Stacy, right? Right, Stacy and Garrard. Yeah. So then Matthew said he bought some land over and above the destroyed forest that he had, and he wants to build a Strawbale house, or a Strawbale building, which will be partly his house and will be part of a center for his ecosystem restoration camp. So this is how I got to be involved in your area. You're halfway between Paradise and Oroville, I see. Is that right? Butte County? Butte? How do you pronounce it? Butte.
Butte County.
Butte?
Yeah,
Butte
and
County.
we are centered in Paradise, this organization.
Okay, okay, beautiful county, okay.
Mhm.
Right, so my thing is I'm a certified European Strawbale builder. I did the course in 2020, and we now run 2 courses a year. The one we run in Portugal has just finished today. It's an 8-week course starting in January, and we had 10% participants. We teach 8 modules, and I don't know if anybody's going to be at the CASPA National Conference at the end of March. I don't want to repeat everything I'm going to say there. But we have 8 modules, one of which is building physics, and that covers the Strawbale and plaster limecrete fire prevention, which is what we're talking about today, right? Fire resistance. As I understand it, the only house in Paradise that survived was the Strawbale house. Is that right? There is a Strawbale house in Paradise which survived the fire.
I don't know. Does anyone know about that? And
I don't know that, but probably about 1 in 10 houses survived. Not all were burned, but most were.
Yeah.
Well, I was informed when I was up there that the Strawbale house survived, and I use it regularly to advertise Strawbale building.
Strawbale house on my street survived. It was the only one on the edge of the canyon that survived the fire. So
Was that Strawbale house?
It was a Strawbale house, yes.
Yay.
The windows blew out, the roof needed to be done, but the structure was intact, and it was pretty impressive. So I
Okay.
can attest
Well,
to that.
virtually every country in the world has done a fire test on straw bales, to the point where R120 is now accepted as quite easily achievable. That's 120 minutes before the straw bale will be burnt through. That gives you 2 hours to get out of the house. That's way above and beyond normal house regulations, which is normally R30 or R60. The reason for that is because we put 3 to 4 centimeters of limecrete on the outside of the straw bale, which the fire has to burn through and crack before it gets to the straw bale. But the straw bale itself doesn't burn because, if you ever try to set fire to a book, only the first cover pages get burned. It creates a layer of soot, there's no oxygen, and the fire goes out. We have tried to set fire to straw bales. It doesn't work. We've put blow torches on straw bales. It takes forever to burn through one. So first of all, you've got 3 or 4 centimeters. That's in your language, 1.5 inches of limecrete on the outside, or clay on the inside. And the fire has to crack through and burn through that before it even gets to the straw bale. And then it has to burn through the straw bale. I can show you, let me just try and share screen. Where's it going? Oh, this is a house we built in Austria last year. Can you see this? Am I sharing it?
Yes.
Okay, so this is part of the course that we give. We talk about the fire resistance. This is just the terminology, what F30 is, F120, the high fire resistance. This is what we aim to achieve in a straw bale building in Europe. And each country, this is the German test, has done an F30 and an F90 test. And this is information about the material which is used, Färbeselplatte, OSB plat, and the graphics, which is 7 centimeters thick. And this was accepted in Germany and allowed a 5-story building to be built. Do you want to see a film?
Brandschutz beim verputzten Strohballen Einfamilienhaus kein Problem mehr ist. Die heutigen Brandschutztests wollen höher.
So I can, if you want to, I can show you the whole film. But you see that this was in Germany. They've given this a full fire test, and this sort of test has been carried out in Portugal, in the Netherlands, in the UK, and presumably all over the US as well. So my thing is that of all the many advantages of straw bale building, fire resistance is one of them. This is a test carried out in France. This is one carried out in, there's another film if you want to see it. Fire testing of straw bales, 1,000 degrees Celsius. No idea what it is in Fahrenheit. But this was a 120-minute test. And same in Australia. So all over the world, we've carried out tests to prove that clay and lime-coated straw bales are superior to virtually any other house building type, and especially when you talk about stick build in America, is that what you call it? Stick something?
Yeah, yeah.
Is that just you mean like a wooden frame with plasterboard on the side? What do you call it? Plasterboard, drywall?
Yes, that's
Yeah.
right.
That's a stick building?
Yeah.
Well, that's going to blow away in the wind in Florida and up the East Coast, and it's going to burn away in California. So that I don't know why America builds houses like that. When there's so much straw, and you can build straw bale houses which will resist both. So that's about as much as I have to say. I can bore you to death with the whole 8-week straw bale building course. But
well, I've got a question for
from
you
the fire
right now.
resistance point of view, that's my story.
Can you hear me?
Yes, you're somebody.
Yes, great. I have a question. My name's Dale. I would just like to know the quality of the bales, the components in the bales there that you're referring to that have this test, compared to what we can get just easily around here. You know, the rice bales and straw bales. Well, how do they compare?
Well, okay, I don't know what your specification is, but what I've read, because you're in inches and pounds and things, and we're in centimeters and kilograms and stuff. So our density is 90 to 120 kilograms per cubic meter. I'm not sure what that is in imperial. but that's the density which will not burn. We have tried to burn a bale of that density with less than 20% humidity, less 2% grains, and our bales are 80 by 50 by 36 centimeters.
All right. I unfortunately took a while to get on. I'm a computer internet nerd, and but I am on now. And my question: are you local or are you?
I'm in the Netherlands. I'm in the Hague.
Okay.
But we build in Austria, the Czech Republic, and Hungary.
Yeah.
and
Right.
now-
Well,
and
you're
now
not gonna.
Portugal.
Then you're not gonna know what our local straw bales are. Then that's my
Well,
point.
I have this. Can you see it? Oh, you can't see that. This is the. Oh, you can't see them.
It's
This is
disappearing.
the Casbah. This is the Casbah Straw Bale Building Book, right? Which I'm reading through. That's the
Yeah.
California Straw Bale Association, and I'm reading through it to try to find out how houses are built in America, or in California at least, and what their specifications are compared to ours. And I have to work now in pounds and inches and things.
Let me,
That's okay.
yeah, let me-
That's homework I should do. I can work off of your specifications and then find out what we have locally and see how they compare.
Okay, I can give you 4 websites that all our stuff is on there. Our whole brain is on 4 websites, because we give this training course. It's a European Union certified course, and it's the only course of its type in Europe, which is why I'm presenting it. Dale, are you involved in straw bale building?
I've been associated with people who've done a lot of natural building, including straw bale.
Are you going to be at the annual conference at the end of March in Nevada City?
I'm sorry, I don't know about it, but I think you probably should get off of me now. I've had my question answered.
Okay.
Yeah.
And
And
move on
Mike,
to your
Mike,
presentation.
could you put, when you're speaking, this is Stacy, when you're done speaking, maybe you could put some of those links into the chat for our
Right.
for
I
our
will do.
participants. That would be great.
I will do that very thing right now.
And we want to ask for questions either to be entered in the chat or until all the presenters are done. All right.
Yep.
So thank you, Mike. I think you're done presenting. We can go to the second presenter, right? Okay.
Thank you.
All right. So Jesse Grimes is going to be our next presenter. He's going to talk about light straw clay and earth bag. Welcome, Jesse.
Everybody.
Hey,
Excuse
Jesse.
me, can you hear me?
Yes.
All right, awesome. Yeah, so I'm just talking about light straw clay construction. Just to answer a couple of questions that just came up. I'm in Grass Valley. I've worked around Butte County. Our straw here is mostly rice straw from the rice fields right there, and it works really great for natural building. So I'm going to talk about light straw clay. Let me share my screen. All right, can you guys see this?
Not yet.
No? Okay. Let me try to share that then. How about now?
Not yet.
No.
Wait. Here we go.
Hey.
All right.
Yes.
Cool.
Yes.
Cool. All right. Can you see the slideshow now?
Yes.
All right. Cool. So yeah, this is a little introduction to light straw clay construction. So a little bit about me. My name is Jesse Grimes. I am a permaculture-based contractor, a licensed general contractor in California. I started this business, Earth Care Design and Construction. Did my first project in like 2014. I've been building it ever since then. This last year, got like 3 employees and a bunch of tools. So we're really ramping up and really able to do some more work now, which is cool. I mostly do ecological landscaping based Like I said, permaculture projects, based a lot around water. I worked for a water district for 5 years, so I'm very familiar with water systems. We do rain tanks, ponds, habitats, ecological gardens, and pollinator landscapes, things like that. So check it out, ec-dc.com, if you want to get in touch. So just a few of the benefits of light straw clay. One of the main benefits here is it's able to be permitted in California, a lot of other states too. So they have adopted a code for California. I've got it right here. I don't know if you can see my screen, but it's not very thick. It's only 10 pages is the appendix for light straw clay. So it's a pretty good introduction into natural building because it's very, very similar to regular stick frame, stud frame construction. In fact, most of the construction is stud frame, and then it's kind of just an infill you do once all that's built. So you could hire a regular normal building contractor to do the framing and then infill it yourself, or hire a natural builder to do that. It's also, because of that, it's possible to retrofit an existing house or do a remodel or an addition using light straw clay, because it just goes right between the studs. It can also be made to look like more of a traditional house. You don't have to, a lot of people don't like the look of cob or straw bale that's all round, and some people like that aesthetic, and some people just want a normal looking house, so it can really fits well into the normal, traditional house. Materials are low cost, readily available. You're using the dirt, usually from on site. Around our area with all the rice fields, straw is relatively cheap, and you don't really need a whole lot of it in comparison to like a straw bale house. Every method has its benefits. I've done straw bale too, but this one I've got more experience with. Like other natural buildings, all the materials are non-toxic, especially, if there is a fire, you're not burning up all those plastic materials, all those glues, all the, we all know about what happened in Paradise and kind of the mess that was. So these are all non-toxic, just straw, clay, lime, and wood, basically. The structure is also vapor permeable, meaning that vapor can move through walls. The house can breathe, unlike normal, traditional construction these days is moving more and more towards a completely sealed up house, vapor barriers, which can lead to problems. But like straw bale or cob, light straw clay, the walls can actually absorb moisture and then let that moisture out, so it moves through, and can lead to a healthier house. A lot of the labor in building a straw bale is unskilled. Once the framing's up and the house is built, there's a lot of just work of mushing the light straw clay into the walls. So a lot of it could be done by the homeowner, or you can have work parties. Nope, I'm gonna go back. The walls can be up to 15 inches thick. That's according to the California code. People do make them thicker elsewhere, up to like 24 inches thick. And your R values, depending on how compacted you make the infill, can be anywhere from 0.8 to 1.8 per inch. So it's not quite as high of an R value as just a regular straw bale, but it's pretty decent. You can definitely get well insulated walls. Also, they're very good at sound deadening. They're pretty much acoustic panels the way they're built. So you could even do an interior wall with this method if you wanted, to block sound between rooms and stuff like that. It's going to work a lot better than your regular drywall and insulation. And then, as we're talking about today, it's very, very good fire resistance. What is I was able to find, I couldn't find any actual tests, when in my little bit of research, but I read one that said it looked like it was up to a 4-hour fire rating, which is incredibly good because there is straw in the wall, but it's all coated in clay. So, if you ever try to burn something that's coated in clay, it's pretty much impossible. So this is a light straw clay house. Like I said, this is an example one. It looks very normal house. This is the inside of another one. It can be finished, very cleanly, or you can do the artistic more traditional natural building look if you want. Or it can just be like a little shack. This is one that I built at a permaculture property in Oroville. It's actually a composting toilet bathroom. So this is a small shack. This is a good project to start with. Build a well house, build a shed, something like that, so you can get familiar with the method and try it out. So we'll be talking about this one today, since this is what I have the most experience with. As you can see, it's just a normal stud frame construction. The only difference is the angles in here. It's called lead-in bracing. So instead of putting plywood sheeting on your house for wind bracing, you have to kind of cut these braces into the wall so they're flush. It's a very old, this is how houses used to be made before plywood was readily available. So it's just slight differences from normal stud frame construction, but you can run your wiring like normal, you can run your plumbing like normal. So it's very, easy entrance into the natural building world. And then you fill in the walls with this light straw clay mixture. So basically, you're kind of taking your straw and you're fluffing it up, you're breaking the bale apart, and then you're making a clay slip, which is just, high clay content soil mixed with quite a bit of water to make kind of just like a slippery mud. And then you're kind of, they say, like dressing the salad. You just kind of pour it over your fluffed up straw, and you're just trying to get a light coating over that straw so it'll stick together. And then, as you can see in the middle picture at the top, there's a piece of plywood screwed into those studs. So basically you're making a form. You'll just get some thick plywood, like 3/4, and screw it in on either side of the studs. And then you're going to compact this light straw clay mixture in there using, a blunt stick, basically. And you're just compacting it up in layers from the bottom to the top. And it dries up and makes a nice infill. This is what it looks like when it's almost finished. You can see that form up there at the top again. And it goes relatively quick once you get the hang of it, especially if you're using thicker walls. It's a little easier to get in there. So this is a kind of drawing of the typical light straw clay construction wall. You've got your stud frames, you've got your infill. There's some bracing in there to keep the infill from moving. You've got a clay plaster, earthen plaster, and then a exterior lime plaster over it, something to protect that earthen plaster. It's very similar to how you would finish a straw bale wall. This is what's called a Larson truss. So this is how you would make your walls thicker, up to 15 inches according to the code. You can do regular 2x4 walls or 2x6 walls. Or if you want thicker walls, you have to do something like this called Larson truss. And this actually makes it much easier to run your plumbing, your electricity, things like that. And you can see in this picture on the bottom, they've got the plywood form to start filling that infill from the bottom, and they've just plywooded the whole outside. That would be removed after the infill is compressed in there. Here's another version. See, this guy's ready to put his mixture into the walls. He looks like he's got like a two foot thick wall there. Well, that's the basic idea. It's pretty simple, pretty easy to learn how to do. This is a little detail. If you're doing a 2x4, 2x6 wall, you have to do a little bit of extra work to basically keep those infilled panels from just tipping out of the wall. So you can see I've got these kind of 1x2s on the studs, and this is bamboo sticks going through it. There's a code for how spaced those need to be. And basically that's just there to hold, like I said, that light straw clay panel infill in the wall, keep it from tipping out. There's a little detail of that right there. So there's a little bit of extra work involved in that, above and beyond your normal stud framing, but it's pretty simple. This is what it looks like, once it's compacted in there and dried, and then a little detail of that lead-in bracing that you've got to do. Yeah, once that's all filled in, and you got to let it dry, you make sure that your infill is dry, let it dry a couple weeks. and then you can start plastering it. This is in the middle of the earthen plaster. And you can just usually around here, most of our soils have enough clay content in them. If you don't, you can get clay delivered from somewhere else. But you know, earthen plastering is kind of an art form. It's good to start on a small project and learn kind of the techniques of doing it, getting your mixtures right, doing a lot of tests. Because if you don't do it right, it'll crack and sometimes fall off the wall. So there are some details you got to learn. There's some flashing stuff you have to do around the windows, but that's actually all in the code. It does a pretty good job of explaining what you need to do. Yeah, you can continue to plaster around. We had a little plastering workshop on this project, so get some people in to help with that. It's probably the biggest part of the job is the plastering. And this is what it looked like when plaster was pretty much all applied. As you can see, this little corner on the front here, you don't want any sharp edges, so you round off your corners. It's kind of the only real difference from a normal house. I mean, you could build these to look like a normal stuccoed house, but you're going to use an earthen plaster or a lime plaster or both. It's important that the covering you use is vapor permeable. If you put concrete stucco on here, it's going to rot the infill because that's a vapor barrier. And then, yeah, this is what it looked like when it was all done. And then as far as fire, like I said, the walls themselves are very, very fire resistant. The earthen plaster is not going to burn. The infill is not going to burn. The studs will char, but oxygen can't get around them. And then you can do, this is kind of just to show you the fire hardening we did around this. This is kind of an example of a fire resistant building. So we've got that metal skirting all the way to the ground, all the way around. This structure doesn't have an attic or any, you know, cavity up on the roof. But if it did, making sure that is well screened, so there's nowhere for embers to get into any flammable part of the building. So if the fire does burn up to here, it might scorch it, but it's not gonna burn the structure down. And then, yeah, so this is what it looked like when it was completely finished. We just finished this pond around it as well. And this is a recent picture. So this building is about almost 3 years old now. And it's standing up really well. There's a few cracks from settling. One thing is if I can go back. One thing I learned on this project is you want to make sure that you have a really good foundation. We did a wood frame foundation on this because it needed to be 2 stories. And in settling, it has cracked a little bit, but that's part of the maintenance of, you know, either a straw bale or light straw clay. Is it will crack, and you just got to go in and re-plaster those cracks basically. And once you learn how to plaster, it's not very difficult. It's a lot easier actually than doing a drywall repair, in my opinion. Yeah.
Jesse, could you just describe the ingredients in the earthen plaster?
Okay, yeah. So the plaster, this one ended up being about 75% sand. So I just purchased some plaster sand from a local supplier, which is kind of a coarse, rough sand. You don't want smooth beach sand. That won't stick together very well. But this one was, yeah, mostly sand. And then about 25% just clay soil from the site here. You know, I think I did a jar test on the soil at this site, and it was, you know, probably 20% clay content. And then there needs to be some sort of fiber inside the plaster to hold it together. So you can use chopped straw, is popular, or on this one I actually used donkey manure because there's donkeys next door to this property. And basically they've already chopped the straw for you. So I just scooped it up and kind of screened it, mixed it in. And, you know, it's not, it's not as gross as it sounds. You can use gloves if you want, but the manure actually works really well as a fiber inside of plaster. It makes it really nice and smooth and easy to apply. if you use chopped straw, you're going to end up with little bits of straw sticking out of your wall, which you have to do with, you know, fine plaster over. Yeah, that's basically it. You want to do a few different mixes. You know, like I did 3 or 4 different ratios of sand to clay, and you know, just put them onto a board and let them sit in the weather and see. You know, some of them, there's too much clay, it's going to crack. There's not enough clay, the plaster won't be very strong. You know, won't be very resistant to weather or abrasion. So you just find your right ratio and then just keep making mixes. This one, we actually mixed it up in a bucket with a drill and a paddle, kind of like you would mix mortar. I just hired somebody to do that. He was mixing and I was applying, and it took us a couple weeks to plaster it.
So no lime or hardening is required to be in the mix to provide some water repellent?
No, you do need to protect that earthen plaster from water. So on the exterior of this building, normally you can do a lime plaster, which I did do on the interior of this building, just mostly to make it white to brighten it up inside. On the exterior, actually use what's called a potassium silicate paint or a water glass paint. There's a brand called Ecologic, which I used, which worked really well. And that, I basically just painted it onto the dried plaster in a couple coats, 2 or 3 coats. And it basically turns into glass once it dries.
Wow.
It's still vapor permeable, but I did what's called a jet test. So I made some test panels, you know, with different 1 coat, 2 coat, and sprayed it with a hose, like on jet setting. And I sprayed the 2 coat panel for 10 minutes and nothing happened to it. So I was very impressed by this paint. Or you could do a lime plaster on the outside, and you can tint your plasters with colors if you want a different color than white. Yeah, so you do need to protect your plaster. And then you can also see I have very large overhangs. Same with any building like cob, like straw, clay, or Strawbale. You need good overhangs. Eaves on your building, protect it from driving rain. Because if you do get driving rain, it will eventually, you know, wear it down, especially if you got cracks. But it's pretty easy to repair.
Thank you, Jesse. That's great.
Yeah.
Jesse, could you just quickly before we move on, tell us what code you're referring to? We had somebody who asked that who lives in Canada.
Oh, I'm not.
I
think
think
it is
John
in,
answered it.
yeah, I think it is in the international code. See that I just downloaded this off, you know, the state website. So in California, it's called Appendix R, light straw clay construction. It's just part of the adopted code. I'm sure you could find it. Just Google it.
Yeah, so someone just added a link to the chat there.
Okay.
California
Thanks,
residential
John.
code.
Yeah. So as far as permitting, it's much easier to permit since there's, you know, you're not gonna have to fight them. You bring them the code and say, look, I'm allowed to do this, you know, especially since they're going to be much more familiar with this type of construction because it's mostly just stud frame. You know, most of the building process is the same. You know, the same slab or stem wall foundation, same electrical, same plumbing, same roof. You know, this is just kind of an infill instead of doing, you know, foam or fiberglass insulation with drywall. You're doing light straw clay with plaster. So,
Jesse, can I ask you a question?
yeah.
All the advantages of your light straw clay list could have been Strawbale. It's exactly the same. But you're using loose straw, right? Mixed with clay.
Yeah.
What is the proportion of each?
You kind of you're taking the bale and you're pulling it apart so all the individual straw fibers are all fluffed up, and you kind of just, I don't know exact ratio. You kind of just slip on there until it feels right.
But you say it's more straw than clay or more clay than straw?
Way more straw than clay. Yeah,
okay.
The clay is just there to basically coat the individual straw fibers.
Okay.
And get them to stick together. You want to actually use as little slip as possible for it
Right.
to stick.
So-
If you
so
don't
you-
use enough,
Right.
they'll fall apart.
You're putting your shutters up and you're
Mhm.
filling it with your mixture.
Mhm.
And what do you do, about 2 feet or 3 feet? And then
Yeah, about 2 feet at a time.
you don't do shuttering right up to 6.5 feet and then fill it in from the top, do you? You do a bit and then you pile it up.
Yeah, you do a bit, because you need to be able to reach in there,
Yeah.
like, so you see this guy on this picture, he's got his 2-foot board,
Okay,
plywood
so-
comes in 2-foot sheets or 4 foot, so you cut it in half and you have your
How long does
shutter.
it take to dry? If it's 15 inches
Um,
thick?
I don't know, about 15 inches thick. With the 3.5 inches, it was dry the next day. So,
Okay.
but the good thing about this construction is you can fill the wall all the way up to the top the same day. It doesn't need to dry before you do another layer like with cob, because it doesn't slump. It holds its form. You do
Okay.
have to wait for it to dry before you plaster it, obviously, but
Yeah. I just wondered how long, if you get a 15-inch wall, which is what we work with, how
yeah.
long do you have to wait before you can take the shuttering off? Or is it all just going to go? Boop?
You actually want to take your shuttering off the next day. You don't want to leave your shuttering off for more than 24 hours, because then you open it up to mold.
And it
But you
doesn't do this?
No, it's compacted in there, so it's held
Okay.
together pretty well.
Oh, very good.
I think you could probably take the shuttering off after like 3-4 hours.
Yeah,
and
that's
it
brilliant.
would
I
hold
mean,
in.
I see this technique as being very useful for the intermediate walls within the house
Yeah,
of a
definitely.
Strawbale house.
Yeah.
Because the insulation value is not so high, and also you can build far narrower walls than we build with Strawbale.
Yeah, that's kind of, every natural building method has its benefits.
Yeah.
But yeah, as interior walls, this would work really excellent. Even if you have a normal, stick frame house right now and you want to do an addition, or just you could tear the drywall off your interior walls and put this in there if you wanted a more
Yeah. Brilliant.
soundproof, or
I'll
just
do that.
Brilliant, thank you.
yeah.
Thank you so much, Jesse.
Thank
Yeah,
you,
you're
Jesse.
We went over a little bit of time, but that was really interesting. So
Okay.
Wayne, you want to introduce Andrew?
Yeah, we have our next presenter, Andrew, who built a 3D printer for cob, and he's going to tell us about building that and give us some pictures of his machine. So go ahead, Andrew, when you're ready.
Can you guys hear me?
Yes.
All right, let me share my screen real quick. Can you guys see my screen?
Yes.
Great. All right, so let's go into it. So yeah, my name is Andrew. I've got kind of a background in engineering, architecture, machining, design, fabrication, construction. I've done stick frame homes. I've done a little bit of natural building, not as much as Jesse. He's a pretty capable guy. But I've got kind of a background in a lot of these things. And when the campfire happened, I set it in my mind to go about building a 3D printer so that we could hopefully use automation to rebuild after the fire. So that kind of set me on the track of looking at the history, or looking at sort of what companies were doing it, how they were doing it. And basically 3D printed construction has been around since 1997. And in the last 2 decades, it's gone from a classroom theory to actually making strides into moving into the mainstream, utilizing 3D printed concrete construction. But there is a company in Italy that is utilizing cob as a 3D printed medium, which was inspiring to me. And so I kind of wanted to take that idea and bring it here to the States. So I've been working to sort of bring that here in California. So I don't know how many of you are familiar with 3D printed construction, but this is kind of gives a basic idea of how it goes. Is the machine goes through a program and it lays out layer by layer a material, either concrete or cob, to then build upon the next layer, one layer on top of another, until you get a full print or a full size structure. So the benefits here are that, you know, you can reduce your construction times. You've got about a 10 to 20 hour print time to 3D print an entire home. You can do it with a minimal amount of work. You know, a lot of challenges with natural building is that it requires a lot of human labor input, and you can kind of utilize automation to bring the number of workers on site down to 2 or 3, and they're mostly there just kind of tending to the machine and making sure that everything's functioning appropriately. You get all the benefits of you know, the fire resistance, the material availability, and the possibility of being actually carbon neutral or carbon negative, which is a really pretty amazing prospect. So the industry currently right now, you know, there's been a handful of structures that have been printed. This one was like Icon in Texas. This one was in New York by SQ4D. This is another one that was SQ4D. But there's other ones. This is in Italy. This was printed by WASP. And there's even a local company, Emergent, that is bringing 3D printing to the Ridge here in Paradise. So we haven't really talked about cob necessarily in the presentations so far, so I'm going to kind of haphazardly throw it together, which is, cob is basically, it's a mix of sand and clay and some sort of fibrous content, straw or other things that can be either chopped or left long and mixed in. And Jesse kind of covered that in his earthen plaster. It's very similar to that. It's just that you're going to go with different ratios depending on what you're trying to do. So cob is done typically in lifts, what's called lifts, where you're doing 18 to 24 inches, depending on what your slump of your mix is, or how capable the mix is of sustaining pressure. So you will lift 18 to 24 inches, and then you'll have to let it dry, and then you'll go another 18 to 24 inches to build your structure. So 3D printing is pretty much the same when you're 3D printing with cob. There's no difference there. You still have time to cure. You have to let the layers underneath dry so that they can actually have the load bearing capacity to support the future layers. So the benefits of cob is that it's ecologically friendly. There's an unlimited supply. It's globally, it's available. You actually have to, when you go and dig a foundation for your structure, you're actually, that material that you're pulling out of the ground for your foundation, you can actually then turn into your walls. You may need to augment it a little bit with a little bit more sand or more clay, depending on what the content is. But it effectively allows you to use the material that you already need to pull out to rebuild your walls. The IRC just recognized cob as a viable construction methodology. It's 100% reusable. If it collapses, or if it, you have a mistake, you can actually just throw it back in the mixer, add a little bit of water, and put it right back into the building. There's no cure times as far as, limitations with construction concrete. You have cure times, so you sort of are under the pressure of making sure that you're building the structure within the limits of the cure time. And if it cures before you actually build the structure, and then you can have problems. So that's the beauty of cob. There's no toxic chemicals, no carbon footprint, or the possibility of being negative carbon footprint, because if you're using lime plasters actually continue to carbonize over time, and they can draw carbon out of the atmosphere, leading to a net negative of 2% carbon carbon footprint. So, you know, we're actually doing a 2% carbon drawdown with this type of structure. It's a local resource. There's little to no cost. It could be free depending on the composition, the soil composition that is in your region. So cob, yeah, is basically, like I said, it can be found anywhere. It's a mix of straw and clay and sand. And it's basically lifts, like I said. So it's kind of, you can see a little bit of the framework that's needed to sort of keep the forms, but mostly the form is actually held by the integrity of the mix itself. So, I mean, it's clay, like you can think of sculpting. It holds its form really well and lends itself to actually a lot of creativity because you can shape it to be any shape you want. You can build nooks, you can build pockets in the walls, you can, it's a very viable, like a very malleable material, which is really, really cool to see. You can get all these interesting shapes that we've seen in some of the other presentations as well. It's also one of the oldest building technologies known to humans. It's been around for thousands and thousands of years. This is a mission that was is here in California. It's at least 250 years old. So these structures actually have proven to stand the test of time. There's other structures that are 2,000 years old that are still standing in places in the Middle East. So cob is an incredibly durable, incredibly, it's an amazing material. Can't really say enough about it. So as far as my journey with building the 3D printer, it's been kind of fun and challenging to, you know, make a mess, make a fool of myself, start stacking material, seeing how it goes and building things and using everything I got to just sort of come up with what I feel like is a really beautiful blending of modern technology and this ancient wisdom of building with raw earth and material to it's just a really beautiful hybridization of the new and the old, and I think it's really fun to see it. So current capacity, I have the ability to produce one printer per month, and my printers can basically I can 3D print a 1,200 square foot home out of cob or concrete. I do need to kind of invest a little bit in bringing the printer to full scale production, but that's kind of where I'm at. But my goal here is to try and stack up or compare with some of the other printers that are on the market, which have anywhere between $250,000 and $1 million price tag. But yeah, so this is kind of my prototype goal here in the next year to 2 years is to try and actually build this first 3D printed home. So I've worked with an engineer. I've had some preliminary discussions with an engineer and kind of coming up with seismic strapping designs and trying to figure out how to deal with the loads. It's sort of 3D printed cob has not been recognized by the IRC or any building code necessarily. So it's sort of on the forefront of what's possible. It's still very much being worked out as far as the logistics and how to assemble a plan set and how to have something that would be recognized by a building official or a building department to be a viable building. But there are engineers who are interested in working on this, and I believe that we've actually come across or have identified some really solid potential seismic strapping solutions. And I wouldn't be surprised if in the next 10 years that we start seeing full automation in cob and natural building. Maybe that's ambitious, but I like to think big. So this is just kind of some exterior elevation, basic ideas, but yeah, that's sort of that. I've got a couple little videos just showing the printer in action here. So you can see this is a mixture. It's about a 75-25 clay sand. There's no straw in this mix, but there would be enough in a production. But you can see that the machine is just doing a really good job of putting out the material, and the material actually has really great stackability. Probably in the future here, yeah, you can start to see that it just stacks one on top of the other without really any deformation of the substrate or the layers underneath.
Beautiful.
So I don't know, it's fun to watch. It's fun to think about automating natural building and future of where things are going to go. But that's kind of my spiel, I guess, for the moment.
Thank you, Andrew. That's really amazing. Really amazing. Beautiful. All
Do
right.
you have a picture of the machine, Andrew? That you built? So you built the machine,
Yeah.
the picture. So cool. And do you have a picture of it? Of what, or not really?
I mean, it's not. It looks like a bunch of metal. I don't know. It's more impressive to see what it actually does than actually see the machine.
It's pretty impressive.
Thank you.
And Andrew, how long did it take you to build it?
I mean, it probably would have taken a lot less time if I had the resources and the funding to actually make it happen. But I've been working on it for the last 2.5 years.
All right, very good. All right, so we're going to enter into the question and answer period. And we'll start with questions from the attendees. And I'm looking at what we have collected from the chat window. Andrew, with the 3D printed cob, is there any reinforcement in the wall? Like we saw with the light straw clay, is there some weight or load supporting members for the roof? How does that work?
Yeah, so I've developed a sort of proprietary way of dealing with seismic loading and strapping. And I've been working with an engineer to sort of develop that. So I don't want to speak too much about it, but yeah, other companies are doing basically cast in place steel reinforced concrete columns that they're doing. We could very easily do something like that with cob, but I've got another way of doing seismic reinforcement, structural reinforcement. But the actual cob walls are load bearing. They have the compressive force of, I think it's like 300 PSF, which is comparable to almost comparable to rammed earth construction. I think rammed earth is like 800 PSF, so it's a little bit less, but it still meets the IRC requirements.
And how about the considerations for plumbing and electrical in the walls?
Yeah, so cob is, because you have to do lifts and allow for cure time, it actually lends itself really well to having to do all your electrical, mechanical, plumbing while your lifts are curing. So if you do your first 18 inches and you have to let it cure, you basically have a platform where you can lay out all of your PEX, all of your Romex, put in all of your outlets and things like that at 18 inches, which is where your standard outlet is going to be along the floor. And then you can kind of build from there. And once you get up to 18 is, the next one's going to be 36, which is right around your light sockets or your light switches. You're just putting everything built in and it just gets printed in. If in the future you want to change things, the beauty of Cobb is that you can kind of chip it out. So you can chip out a channel for wherever you want to put your conduit or your electrical runs. And then once you're done, you can just plaster over it. You just fill in the hole and it's like nothing ever happened.
Nice. All right. And I think a couple of these questions were answered. Here's another question that just popped up. Is the printer something that is already patented? And if so, are you considering crowdfunding for production of more machines?
The printer cannot actually be patented. I believe it's covered under Creative Commons because the original 3D printer was actually developed as a sort of collective of a brain trust that evolved out of a forum online somewhere or something like that. So no one owns the patents on a 3D printer, which is really cool because it's owned by everyone. Like we all own it. But as far as crowdfunding, I have not done any crowdfunding. Everything up to this point has been self-funded. But I have been looking for grants. I've applied for a couple of grants with North Valley and Suchi and a few others, but I've been denied grants up to this point. So.
All right.
Hopefully that will change. Can I read a question that we had early on, Wayne?
Sure.
From Susan. She had a question for Mike, and maybe any of the three of you might be able to answer that. She says, I'm happy to hear there was a Strawbale house in Paradise that survived the fire. Can't believe I hadn't heard that before. An architect who is on the board of one of the nonprofits I'm on has said repeatedly that Strawbale is not a good idea for this area because of the amount of rain we get in the winter. What do you think of that? I feel like the gentleman who's from Scotland and now lives in the Netherlands and focuses on Strawbale probably has something to say about that.
Well, yes, I did actually answer it, but I don't know how much rain you think you've got over there, but come to Austria, come to Norway, come to Scotland. We've got rain, we've got Strawbale houses. Jesse said on his little house that he built, you see a large overhang. That's like an umbrella, and that keeps the majority of your rainwater off the walls anyway. But we coat our houses with limecrete, like I said, which is fireproof, but it also is water resistant and it is rodent and insect resistant. Lime is a wonderful stuff. When it has gone through its chemical course, it becomes limestone again and is very hard on the outside. But it's waterproof, and a properly built house, properly plastered with lime on the outside, is perfectly waterproof, and we've never had a problem. Sorry, in my experience, we've never had a problem because we build houses. We visited a house in Portugal last month. Guy built a Strawbale house, didn't know what he was doing, didn't put down a damp-proof course, and he had water come up from the ground all the way up the wall, rotted his straw bales and everything. If you don't build a house properly, of course you get problems. But a Strawbale house, like a light straw clay house, are perfectly resilient to rainwater.
And
I
so
think,
maybe
Jesse, would you agree?
Rachel, maybe some of this might answer your question about how Strawbale performs in colder climates. as
Strawbale is
well.
ideal for colder climates. It is the ultimate insulating material, and it's free. I haven't come across a negative argument against straw yet.
I was going to add that I believe from handling regular straw bales and rice bales that the rice is denser and I think also holds together better. It really is a pretty tight bale. I use straw for my animals in the barn, and I really prefer regular wheat straw for that, because the rice straw is just so dense and holds together so tightly, and it's pretty heavy. A bale rice straw.
I've never worked with rice straw. It's one of our least favorite because apparently, from what I hear, the clay doesn't stick to it very well. It's a shiny home, where we use winter wheat as our preferred cereal straw.
Right. And you know, that's something we didn't talk very much about, was the energy efficiency benefits. And Mike, you just mentioned what an excellent insulator straw bale is. And Jesse, I wanted to ask you, with the light straw bale or light straw clay, you're getting some of these benefits depending on how thick the wall is, but could you kind of just briefly go down what you think the major benefits are to the light straw clay?
I think, you know, it's pretty similar to straw bale in its performances, but I think the major benefit of light straw clay is how similar it is to regular construction. Because it's more approachable for people who are more familiar with that type of construction. Whereas straw bale is a wonderful method, but there's a lot of, you know, particular skills you need to learn in order to do it right. Like he had talked about, somebody building a house not really knowing what they're doing and ending up with big problems. Most people know how to build stud frame walls, and it's pretty hard to mess it up with light straw clay. As far as the energy efficiency benefits of it, that's why there's that range of 0.08 to 1.8 R per inch. It depends on how much clay you put in the mixture and how tightly you pack it. If you pack it really tight with a lot of clay, it performs more like a mass wall, like a cob, which has its own benefits. If you put a really nice high mass wall in the sun in the wintertime, it's going to absorb heat and then radiate that out through the nighttime. So that you can change your ratio depending on what you need, which is kind of a cool benefit of it. But yeah, just kind of the thicker the wall, the better the R value you're going to have. But it's not quite as insulative as straw bale, and they're both wonderful methods for around here. It depends, we don't get that cold around here unless you live way up high in the mountains.
So would you say that the fire resistance is one of the major benefits of light straw clay?
For sure. It's
right.
I mean, like I said, what I read is a 4-hour fire rating, which is ridiculously high.
Yeah.
I'd be challenged to burn a light straw clay wall with plaster properly applied.
And we had.
Andrew, can I ask Andrew there? Maybe you were just going to do this, Wayne. Somebody asked about if you could just speak to the fire resiliency of cob.
I mean, does the earth burn? It doesn't burn. It's just clay. So, okay, here, clay. A crucible is a crucible is made out of clay. A crucible is used to melt steel. So if steel is going to burn and melt inside of a crucible, then clay is not going to. You have to have immense time and heat for clay to actually melt, or that's magma, that's a volcano, yeah. If your cob house is burning You should not be anywhere near that place.
All right. And we had another question, I think, for Jesse, related to the vapor traveling through the straw clay walls being permeable. Is there a benefit in sealing the studs, the 2x6s before framing?
No, you'd be wasting money doing that. They're not. So vapor permeability is different from water moving through the wall.
Right.
It's water vapor in the air. So, wood studs can be exposed to water vapor and be all right. If they get wet, they're going to rot. But the benefit of a vapor permeable wall system like Strawbale or light straw clay or cob is that vapor can move through the wall in times when it's high humidity or rain, and then when it gets dry again, that vapor will leave the wall. Whereas if you have a vapor barrier, like most modern construction is all about vapor barriers. That vapor is going to move through the wall, hit that vapor barrier, and condense into water droplets. And that water is going to rot out whatever's there. So that's why modern houses using vapor barriers have to be very tight, have to be very waterproof, because water is the enemy of any house, be it straw bale, light straw, natural, whatever. You don't want water in your walls. But if that vapor doesn't ever hit a vapor barrier, it can move back out of the wall can breathe, it can dry out, and it'll last a really long time. That's why you don't want to put concrete on top of cob or straw or anything, because concrete's a vapor barrier. So you want to use an earthen plaster, lime plaster, something that's vapor permeable. And then I also saw another question in here about the studs. It says somebody has to do the studs act as thermal bridges in light straw clay construction. Yeah, they would. If you're just doing a 2x4 stud frame wall, same as with a normal conventional stud frame wall. And yeah, the Larson trusses, I'm not familiar with the decoupled staggered stud framing, but the Larson trusses are pretty easy to build. And yeah, you're using those to create a cavity of whatever width you need. And that is going to be much more insulative if you don't have that thermal bridge of the stud all the way through the wall. The Larson truss wall would actually be easier to fill too, because you can get in from the top and compact. With the 2x4s and 2x6s, you got to get a stick in there in between your forms, your shuttering. It's a little tricky, but yeah, that was a good question.
That was actually my question, but I just had one add-on piece. Does that mean also on the interior, then when you're doing finishes, you shouldn't be using any sort of paints that would cause you to create a vapor or an air barrier on the interior?
Yeah, you don't want to use any latex or oil-based paints. You want to use stuff like that potassium silicate paint, or natural paints like milk paints or natural pigment paints. You just got to make sure it's vapor permeable, because if you put a barrier on there, it's gonna perform poorly.
Thanks.
Here's a question for all of you. No one really talked about this. What about the fire safety of the roof? What do you recommend? What do you think is the best?
I would say metal roofing. Metal roofing with around here you have to use Class A fire rated materials. So metal roofing with the proper underlayment is going to perform better than anything. Mostly because there's not really anywhere for like leaves or pine needles or things like that to get stuck on a roof, as with like a normal asphalt shingle roof. And that's really what burns houses down, is flammable materials stuck on the house.
Right.
I think I would like to take a stab at that as well. Most structures have yes, 100% Jesse is right, metal roofing, but then I would go so far as to say, if you can actually get away from wood framing for your roof assemblies and move towards steel studs, and things like that. If you're really in a high fire zone, moving towards materials that just don't burn. Most steel studs are actually utilizing 100% recycled material and or a very high percentage of recycled material. There's a lot of steel is readily available. Steel studs, they don't burn, they stand up a little bit better. So as far as your roof assembly goes, just look for building things that, building with materials that are more durable, less fire resistant, or, you know, that don't burn, basically.
In Europe, we put up, in the houses that I've been involved in, 4 centimeter thick ceiling, double tongue and groove ceiling, because a very beautiful pine wood finish. And when it's screwed up onto the rafters are 36 high, so you can stand on them, and you stuff the straw bales in between the 36 centimeter rafters in the roof. So you get a 36 centimeter thickness of straw bale in the roof, and then it's covered with a fiberboard, which is diffusion open, breathes. Yeah, and then there's a ventilation area, and then there's a roof on top of that. You can put your green roof and your solar panels on top of that. So again, you're having to, if your fire's on the outside, it's going to have to fight through 30 centimeters, and then it's got to go through 4 centimeters of wood before it actually gets into the house. So the roofs that we built are totally fire resistant from the outside.
Thank you, Mike. I'm glad that you mentioned the green roof.
Yeah.
What Jesse, Andrew, do you have anything to add about green roof on that topic?
I would say as long as it's well irrigated around here. If you got dry vegetation on your roof, it's probably a bad idea. But there are a lot of really good green roof solutions now that, you know, you're going to keep well irrigated most of the time. Yeah, it can be done. I think the mostly, you know, most roofs they're all fire rated. They're all, you know, rated to have a big burning ember fall on them and be good for a while. Like I said, it's dirty gutters. It's leaves against the house. That's what burns your house down.
Right.
I think the only thing I would say is they're a lot heavier. So you require a lot more engineering and structure underneath them to support the loads of the soil and the water and the plants and a live load of someone climbing up on top of it. So you just need to work with your engineer to make sure that your structure is built appropriately.
And I've read a little about incorporating recycled paper instead of straw as a way to repurpose waste material and sequester carbon. Are there any other materials that you've seen used incorporating in cob or in plaster, like maybe like biochar?
Well, recycled papers like paper mache is
Yeah.
cellulose. That's used here on internal walls between, I mean, what you call drywall. You get 10 centimeter wall with drywall, except we're using fiberboard on the outside, and you can stuff that with cellular or sheep's wool. Sheep's wool is another abundant natural material which nobody's using at the moment. Very few people use it. So clean sheep's wool is a very good natural insulator and another waste product. That's also used here as insulating material in roofs. And another one is recycled jeans, cotton, made into a sort of wool, and you can buy it in rolls. It's kind of, I guess, 4 inches thick, and that's used also in ceilings and attics. There's a lot of recycled materials. There's probably far more coming on the market. There'll be somebody recycling plastic bottles into insulating material, no doubt. But yeah, we use everything you can think of.
I've done a lot of work conventional fiberglass, and I hate that material. It's just, it gets in your skin, your eyes. I really don't like it.
Dreadful stuff.
First invention ever.
Yeah, and terribly energy intensive. I mean, it takes an enormous amount of heat to create that mark. and nobody likes it.
Right.
I mean, you
Yeah.
get Strawbale lying in the fields for free.
Right.
And again, it's lack of education, basically. You know.
So this brings me to my question, if I might butt in here. Like, what are we doing? I mean, this is kind of it's kind of a rhetorical question, but it's kind of not. I mean, I've heard, and maybe Andrew or Jesse, you can address this. This is what has stuck with me since like the second meeting of Campfire Restoration Project, right after the fire. Talking about cob, rebuilding with cob. We have all this rice straw available from the valley because this is a huge rice growing area. And supposedly Paradise sits on this, like the whole hillside is clay. So we just like have all this resource that's totally available for this town that burned down. And we can rebuild houses, maybe not, you know, giant McMansions, but we can build shelter pretty quickly for like very little money. So really, and all the ideas that we've talked about here today that we've heard are so inspiring. And this is just like a tiny bit of what's going on out there in the world. It's like, what are we doing? Is it just like capitalistic resistance? I mean, what's going on?
We are preaching to the converted. We know this.
Moment.
We believe this. We know it works. But try to get that through to the schools to teach it and the colleges and universities to teach it as a building method. Get through to the building companies to stop using concrete and steel. Get through to the lawyers and the governors and the legal people who give the permits out for building, and make them understand that this is a natural resource which is better than what we're using now, cheaper than what we've got now, and anybody can do it. I mean, we have houses here with children's handprints in the clay because the children helped to build the house. Yeah, seriously.
Nice.
You don't need to have a 4-year degree in house building to build a Strawbale house. Anybody can do it. And as you say, the material, the clay, the wood, and the straw is literally lying around.
Yeah.
So it's why we teach it. We have a school of teaching this to try to spread the word. But if you don't get through to the local authorities who give the permits, and we have the problem here, we have it in Holland and Austria, all over Europe, we have a problem with the authorities giving permission to build a Strawbale house, 3 little pigs, blow away, burn down. You know, the stories just get repeated, and you have to educate people. But yeah, talk to Strawbale. I mean, you guys invented it. The Nebraska method is what we still use. That's the load-bearing house, and we call it the Nebraska method because you guys did it first. Tell me.
And when was that, Mike? The Nebraska method?
It was in the 1860s. No, when the baler was first invented, it was about 1870, was it? And that's when they started to use straw bales, because they had bales, because they had baling machines. The oldest house in Europe was from 1920, and it was built after the First World War, just south of Paris, and it is still standing, and it's the headquarters of the French Strawbale Association. And it was built by a guy who had to build himself a house with what materials he had, and he built it out of straw bales, and it's still there. Yeah, I don't know what the oldest one is. I think it's called the hay house somewhere in America. It's actually built with hay. It's actually green stuff growing out of the walls.
Yeah, I love the using the natural materials and the cost savings and the labor that a non-professional can do, but the energy savings, the energy efficiency is so important. And you know, this aids in keeping the house warm in the winter and keeping it cooler in the summer. So it's year-round energy efficiency savings, which is really significant. That's a big expense for people in their budget and with just you know, energy production. People are using you know, oil and
CO2 is in materials, it's in the straw, it's in the wood.
Right.
What do we do with it? We've got tons and tons. I mean, okay, we've got this war going on in Ukraine, you probably know. Ukraine produces something like 600 million tons of grain how much straw is that?
Yeah,
And they're going to have to rebuild. So one of the things we're looking at, just to go off at a tangent, is helping Ukraine to build Strawbale schools, because they're going to use concrete and
Beautiful.
steel to build blocks of flats. But we were going to build primary junior schools in Ukraine when the war's over. But before that, we're looking to build them in Turkey, where the earthquake has caused so much destruction, is to build Strawbale houses, because Strawbale houses are earthquake proof, fireproof,
of
waterproof,
course.
heat proof, cold proof. You want a lecture
Yeah.
on Strawbale building?
Yes,
But so we're looking to work in Turkey with the Turkish Strawbale Association to help build houses there.
beautiful.
Jesse, were you going to add something to Mike?
Yeah, just on the top of your question, what are we doing? Why is this not happening? I think he hit on it. It's education. It's not a new technology, these methods, but it's unfamiliar to building departments. It's unfamiliar to most people. And so if you are going to try to permit a natural building, you're going to have to educate your building department, because they're all about risk mitigation. They don't know what it is. They don't understand it. They can't assure that it's safe, and that's their job, to assure that it's safe. It's not going to fall on somebody. It's not going to burn down your neighbor's house, whatever it is. And so you're going to have to educate them on doing this. And there's a lot of organizations that are doing good work. You know, the codes that have been adopted by California are the result of decades of work by organizations trying to get these codes, doing the testing, doing all the work to get them adopted into the international code, and then state by state. So the more of these houses that get built, the more building departments understand and are familiar with it. They're not so afraid of it, because they know plywood and studs and everything you can buy at Home Depot. Everybody knows that stuff. It's well familiar. Concrete's well familiar. They can say, yeah, you're going to build a house out of cinder blocks. We know how that performs because there's decades of testing and real world experience. So it's education, you know, like any new building technology's got to be proven very well before they're going to adopt it widespread, you know.
Well, I am happy to say that one university in Austria has accepted adding Strawbale building to their curriculum.
Good.
So small
Nice.
steps, but I mean, it's too late, I think, to save, you know, global warming or climate change, but because the whole thing is run by money, and these enormous building companies like the pharmaceuticals and the banks and the oil companies, they run the world, and the enormous building companies are going to insist on using concrete and steel. We're the little guys, and I've given up worrying about it. I'm 72 and I can only do what I can do for the days that I've got, and I enjoy it, and I teach it, and I spread the word, and I talk to people, and I bore people to death with the same old mantra that there's nothing better than Strawbale building with clay.
Mike, could you put a link to the course you were referring
Yes.
to in your presentation?
Yes, I was looking for that.
Thank you.
Yes, let me find that. Yeah, let me find that.
Thanks.
If anybody in the audience would like to ask a question, go ahead, unmute yourself or raise your hand and you can jump in.
This is a question for Jesse. Hi. This is a question for Jesse. I wonder what the difference between the 15-inch and the 24-inch on the Strawbale and code is about.
What do you mean, like the?
Well, did I understand you to say that 15-inch was the maximum they allowed or the minimum? And was there some kind of a code against 24-inch on Strawbale?
I'm just referring to the code that's been adopted by California. And yeah, in that code, the maximum width is 15 inches. In just general light straw clay knowledge, you know, people doing it throughout the world, I've heard up to like 26 inches thick. You know, I think a lot of that has to do with drying time, because you have to make sure that your walls are completely dry before you plaster them. And you know, the thicker the wall, the better insulative performance you're going to get. But if you want to build a permit in California, 15 inches is as wide as you can go.
Thank you.
It seems like one of the biggest concerns of the time, the cost of housing. You know, it's becoming everywhere. It's becoming humongous. It's unbearable, especially for younger people or retired people. How can we combine the two concerns, cost of housing and natural building? And I'm thinking in particular, especially looking at some of the houses. I mean, apparently people are interested in building, especially with clay, cob. Don't necessarily are looking at building a McMansion. You know, they're on Versailles. It seems to be like smaller structures. So yeah, what kind of push could be made to combine these two concerns? I'm thinking of the Casita Coalition in California, for instance, that's very, very active in promoting smaller housing, cheaper housing. How can we see these two worlds basically combine and offer the average person the means to build something that is affordable and healthy?
Yeah, I think on that, I think it's important to encourage laws like, I think Butte County has Title 12 or something like that, like laws within your local county usually that allow owner builders to, you know, to build something a little simpler, a little cheaper, because most of these technologies, most of the work, if not all of it, can be done by the homeowner. It's pretty unskilled. But you know, building a house is super expensive just to get through all the permitting processes, and you know, they want it to be a certain size, you have to use certain materials. Working with either organizations like, I forget who you mentioned, but that are working to build smaller houses, working to change the laws. I would really like to see, you know, something in the ordinances and the building code that says if you're an owner builder, you want to build a house that's, you know, less than 1,200 square feet, you don't have to meet every single engineering spec that you would for a commercial building. That's how it is nowadays. You know, you gotta get engineering, you gotta get drawings, you gotta get everything. Making it a little bit easier for the owner builder to actually build their house without so much, you know, paperwork and back and forth with the county. I think it'd make it a lot more affordable because the materials are dirt cheap. You were building with dirt, you know. It's the rest of it that brings the cost in. You know?
There's the 4 websites that I tell everybody everything is there.
I'm not sure how to pronounce your name. Katarzina? Our friend.
Katarzyna, yeah.
Katarzina, hello. You posted a beautiful photograph of something that looks like a very old building.
That was what Mike was referring to, old building in France. This is from Paris. I think it's over 600 years old.
Oh, look at that. Jesse, that looks like something you might do. Can you see it in the chat?
Yeah, so this is super interesting. I just popped in on this call because someone had sent me the link because they know that I'm interested in 3D printing with clay. But I work for a company where we get funding from the Canadian government and experiment with innovations. So any sort of innovation in green building to reduce carbon emissions or improve energy efficiencies. And I keep pushing some of this vernacular technology that everyone wants to try, these magic, you know, these magic products that no one knows how to use, you know, no one, the technology hasn't been proven. So so this is really refreshing. Thanks everyone for your talks.
Yeah, there's some proven technology right there in Paris.
Well, yeah, for sure. And the most interesting part, I did a lecture at the University of Calgary a little while back, and I was showing igloos and how economical it was that when an Eskimo would build an igloo within an hour and a half, they would utilize only the amount of blocks made from the circle in which the igloo was built. And it was just so fun to, compare that, how resourceful we were in the past. And of course, I wasn't suggesting we go back to live in igloos up here in Canada, but just, the technology and the techniques exist. And to hear that that's what happens with some of these straw bale and clay buildings, that you are just utilizing what's in your space and that it can be decomposed and go back into place when you're done without leaving, toxins, or that it's inert, is just, it makes me glow. I love hearing that.
Yeah, that we're literally walking around on this stuff, right? It's like the earth is saying, here I am.
These timber framed houses, I mean, they're all over Europe. You see in England and Shakespeare's country, but all over France and all over Germany and so on. But it's just it's very similar to what Jesse built. It's a wooden frame filled up with adobe or clay. That's the white stuff in between, yeah. I mean, that,
right.
Where Jesse discovered, telling us this, it's new, and it is to us. It's new to our civilized world, but it's as old as cave dwellers. It's clay and wood. Come on. And that house has stood there for 600 years, and there's hundreds of houses like that, and they don't burn down, and they look beautiful, and everybody wants one. And we still build with steel and concrete.
The thermal bridging in that building looks brutal, but there's things that we are able to improve on now that we know. But I agree, it's gorgeous.
Well, you can insulate on the inside. I mean, we do a thing called wrapping. Do you know what wrapping is? Does everybody know what wrapping is?
No.
Okay, you take an ugly building, not like this. You take an ugly building and you put a wood frame around the outside, very similar to Jesse's, and you put in 28 centimeters of straw, and you cover it in clay, and you literally put a woolen sweater over the house, and that has an enormous effect, and it completely changes the character of the house, because your windows are now, or your walls are now 3 feet thick, 2.5 feet thick. I don't know. Anyway, they're huge big walls. And you've got so you put in windows like at 45 degrees sticking out, so that because your walls now so much further out from your windows, and you completely change the aspect of your house, and you can, as you say, you can cover it in clay and in pink or yellow or green or white or whatever, and you've totally insulated your house for very, very little money. And not every house can do that. If you've got a house which is literally on the street, you can't move it out a foot, but you can insulate on the inside, which means you lose space in your room. But a house like that French house, you wouldn't want to wrap on the outside because you'd lose the aesthetics. But on the inside, if you've got big rooms, you can easily put on 6 inches of straw and diagonal bracing or any kind of cladding, whatever you want on the inside. It can easily be done very, very cheaply, and nobody does it except us. Called wrapping. Look it up.
And this is a question for all of the presenters. Does anybody have a link for our local community for someone who will help build a straw bale?
Casbah.
Casbah.
CASBA. I'll look it up in the book. I've got it right here.
Yeah, if you could put that on the chat, that'd be great.
Yeah.
And Jesse, should people in our county contact you, or is there someone more local that we would
I will
better
go
connect
to
with?
Paradise. I will go to Paradise for the right projects. But it is quite a drive. If you're going to build a full house, that'd be too much for me up there.
Right.
Definitely happy to come up and consult. If you're going to build it yourself, need a little bit of advice, I'd be happy to help out. Yeah.
And I had a question for Andrew. I know that there are still some code issues for a house, but what could you do without code limitations as far as an outbuilding, say like a workshop, a barn, a storage building?
mean, yeah, we can 3D print whatever you want to print. I mean, just
I
if it's
mean,
not
like,
permitted, you run the risk of having it torn down.
Right.
But yeah,
Even-
I would imagine
even
outbuilding.
right.
It depends on, it also depends on your, it depends on your zoning. Like if you're zoned ag, you're allowed to do outbuildings for horse stables or animal stalls or things like that. As long as it doesn't have plumbing and electrical,
Right.
then you can essentially build as big a barn as you want. We could build a barn if you wanted to. It doesn't matter. But if you get into more, your zoning is residential or things like that, then you're more restrictive as to what you can do.
Right.
But again, as long as there's no plumbing and electrical in there, like you can get away with probably quite a bit. But I'm probably going to be printing some unpermitted structures here very soon.
Let me in on that. Let me in on that.
Don't tell anyone.
Yeah.
Oh no.
Yeah, I do know in Butte County, I do know the ordinance is if it's 120 square feet or less.
Right. Right.
You don't need a permit. It
Right.
just has to be, structurally sound. But then if you do put electrical or plumbing into it, you need to pull permits for that stuff. So like that bathroom I built, first of all, it's a composting toilet. It's a commercial system that's permittable in other states, but not California yet. People are working on that. So we weren't going to try to permit that. It's bending the rules a little bit because it's sort of 2 stories, but a lot of it is, I wouldn't build a whole house unpermitted if it's your living structure because you could be forced to tear it down, which would be horrible. But a lot of the building departments are neighbors. If they don't complain, then the building department's not going to come on your land. So, if it's a well house, a storage shed, a little kids playhouse, a guest room, you can put a bed in there and a heater, and have a little guest room for somebody sleeping in your backyard. As long as it's under 120 square feet, or I think the roof footprint is 200 square feet. Because they are going to fly over or look at Google Maps, and if they see a bunch of roofs on your property, they might come knocking. But if it's small enough, it's in the ordinance. You're allowed to build sheds. It's basically a shed.
Right. Right.
Yeah.
So has anyone ever gotten, we've talked about this before, like building a series of 120 square foot domiciles that are maybe connected by breezeways or not? I don't know, but
Yeah, in Oregon,
this one's your bedroom, this one's your.
That's how a lot of people up in Oregon did that. Especially a place called Cobbville, which was one of the first. Ianto Evans, he kind of brought cob to America, and it was 200 square feet in Oregon. So they build 200 square foot kitchen, 200 square foot bedroom, bathroom, and then they connect them with little greenhouses. So you can get around it.
So that worked out for them?
Yeah. I'm sure they had their troubles. I mean, that's unfortunately the ordinances and the codes in America and California are pretty, they're in the past for what a lot of people need. But I don't know the real solution other than just continue to pressure the counties to change. I'm sure there's people working on it, support them when they can. It's not something I want to do. I'm not interested in it, but some people are interested in that or are working on it. So give them support.
I think you can also do a lot with low voltage systems. Like if you're using 12 volt systems versus 120 volt, I think you can also bend the rules a lot more there. Like looking at RV appliances and things like that, you can actually keep things at 12 volt, and that doesn't require a permit as long as it's low voltage.
Mm-hmm. Okay, thanks.
I had a question about this is something that comes up with sustainable and green building in general, and maybe whoever wants to answer this. What are some benefits in terms of healthier living, like healthier environment? A lot of new construction, new cars, new buildings, new materials have VOCs, right? So I imagine there's some benefits with less toxins.
I mean, most modern building materials are incredibly toxic in either their manufacture, their use, or their, burning, their destruction. Natural building materials are completely non-toxic. And then, as I said, with the vapor permeability of the house, when you have these modern, super tight, airtight houses, they rely on mechanical ventilation. And if that fails, you can run into mold problems. There's something called sick house syndrome. Some people are very sensitive to that, and they can literally be made sick by their house. So this is natural materials that we evolved to live with, and they're perfectly fine for us. So there's a lot of health benefits to it for sure.
But also the sound quality. A lot of sound studios, music recording studios are being built with straw bales now because the sound quality is so good. The healthy, we say the humidity balance and the temperature balance. There's no swings in temperature because it takes so long for the heat to get out or the heat to come in. That the humidity and the temperature is constant. It's also far more beautiful looking because you've got all the rounded windows and door frames and everything. It's just a lovely thing.
And maybe we can't get a precise number, but can you characterize cost per square foot compared to stick houses?
Okay. Here's a thing, because people ask us a lot. If you use, I can only talk about straw bale, but if you use straw bales, you can save a few thousand. If you do the work yourself and bring in friends, you can save a few thousand. But basically, the cost of any house is the cost of the land, the soft costs of the architecture, the administration, the permits, your sewage lines, your electricity lines. These are all the same. Your kitchen and your bathroom cost the same. Your decorations cost the same. So the house in total costs, basically, if you're talking like in $200,000, you might save 10 or 20,000 on materials and labor. But you're not going to get a house for like half price by using straw bale. The land is the land. Whatever your piece of land costs, that's what it costs. Whatever building you put on it. Putting in your connections to your utility lines, it's the same. People think, straw bale house, that must be cheap. Not really. And the more friends you bring in, the more family you bring in, and the fewer professional builders you bring in, then obviously you're saving money, but you're not saving vast amounts. Am I right? Would I say, Jesse, would you say fair enough?
Yeah, absolutely. I mean, the labor costs are a bit higher in natural building. Material costs are lower, but labor's more, so kind of evens out in the end.
The labor's only more so if you pay professionals to do it.
Yeah, if you're paying people.
Anybody can stack a straw bale on top of a straw bale.
Yeah,
even I can do it.
And your ongoing savings with energy costs would be significant.
Enormous.
Yeah.
That's really the long-term benefit, because your heating or cooling is so much less. I don't know if you know Michael Reynolds and his Earthships, passive houses, this sort of thing. I mean, these are really comfortable and very low-cost, energy-efficient houses. Oh, I'm going to ask Jesse, have you ever used bottles in your walls?
No, I've seen it done. I haven't done that particular method. Yeah.
I collect bottles, and I have bottles to go into walls. I have got thousands of them. I'm just waiting for a house that wants them.
I've collected bottles for sure.
Yeah.
I don't have my own land yet, so I haven't experimented with that.
And does anyone have something to add in terms of resale value? Like once you're ready to sell your house and move on, are you going to?
It's certainly in Europe. People want to be, well, maybe greenwashing, but they want to live in natural houses and say, hey, I'm got an electric car and
Right.
Yeah.
and the solar panels, and I live in a Strawbale house. It's very fashionable.
Right.
As well as
Yeah. So I imagine 10 years ago, it might have been harder to sell a Strawbale house, but
Yeah.
I think now it's
Yeah.
going to be easier.
Yeah.
There's going to be a market for people looking for that.
Yeah.
Right. Marketable.
I think in your
Yeah.
area where well, I don't know if forest fires are a problem anymore because there's nothing left to burn, but if people could be convinced, maybe see demonstrations of how either light straw or Strawbale houses, so light straw clay houses or Strawbale houses don't burn, they might be more encouraged to invest in them and to take part.
Mhm.
I've been up. Do you know Matthew Trum?
Yeah.
Yeah.
I'm working with him. Yeah.
Right. Well, Matthew Trum's the guy who wants to build a Strawbale house in Oroville. And
Yeah.
so we went around to his place, same as Jonathan Cabot took us around his place. I mean, it's heartbreaking, as you know, to see these black forests. It's just incredible. So that's why I say there's probably nothing left to burn up there.
I wanted to say, speaking of Matthew Trum, if anybody wants to come out and see the building I was showing my presentation, Matthew's helped me put on a tour of that property on April 15th. There's going to be, I'm going to do a talk about what the water systems there, the ponds, the water harvesting. There's going to be talk about the edible plants, and then another talk about composting. So we don't have the event page up yet, but you can go to treetoppermaculture.org and it'll be up there in the next few days. That's April 15th. Go check it out.
Awesome.
Cool.
And that's in Paradise, Jesse?
It's in South
Or
Oroville,
Oroville.
kind of near Feather
Oroville.
Falls, Dunstone area.
Okay.
All right.
Awesome. Well, thank you, everybody. We have a minute or two left. If there's any last questions from the attendees, anybody with a final question?
I just had a thought, and I don't know if it makes any sense. We have, I was about to say a shit ton,
So
but
I
it may not
don't
be
know
very
that off the
polite.
top of my head, but I can get that information rather quickly. I can send an email to my correspondent over there. She usually
Oh, I
emails.
think she needs to be muted.
I think she's talking to someone else.
Yeah, so I was just thinking about wood chips. We have so many wood chips available in areas that have burned in particular. Could we possibly use them for straw? Could you combine them in play?
You can use wood chips in a light straw clay or light chip clay basic capacity. I don't know if it's in the code yet, but it's definitely, you could use wood chips, you could use rice hulls. There's a few different materials you can use. Yeah. I mean, somebody mentioned in the chat, Miguel Cabalot, or he's doing these pallet cob structures. Not permittable yet, but he's using everything from cardboard to plastic bottles to old clothes to whatever you can stuff in the wall. He's using it and then covering it with an earthen plaster. And it works fine. Yeah.
And something I asked before, do you need vents in a breathing house?
I think Mike might be a better person to answer that.
Do you need vents? Did you say?
Yeah.
Ventilation.
Yeah, I mean, there are various ways of natural ventilation. When you're first building your house, like when you're putting in your underground sewage lines and everything, you can put in large pipes, generally plastic pipes, which come into the back of the wall and give ventilation. And then you could put a solar chimney, which is normally a metal chimney, which is heated up by the sun, and the hot air rises inside, and it draws the cold air in from outside through your house and up through the chimney. That's natural ventilation. And you put a couple of little doors or flaps on it to stop the raccoons and things getting in. But that is natural ventilation. But then you could stick a fan in it and make it forced ventilation as well. But a solar chimney sucks, the hot air rising, sucks the cold air out of the house, or hot air out of the house, and brings the fresh air in from outside. And if you set your pipes up in the prevailing wind direction, then the wind will tend to also force its way through the pipes. And if it's hot air, it will lose its heat because it's underground, and it'll lose its heat to the ground and come out as relatively cold air into your house.
Mike, do you live in a straw bale house?
I wish.
Oh,
I live in a Dutch concrete reinforced block. And I do.
Someday.
Jesse, does your house have light straw clay fill?
No, I'm
Uh-oh.
renting a house from 1940 that costed $400 a month of heat right now. So it's pretty bad. Yeah.
Certainly Andrew lives in a cob house though. You're muted. Still muted.
Why won't it unmute me?
It did for a second.
I'm using 100% recycled denim insulation, and I think the reusable materials in my house is probably around 75%. So I'm doing what I can.
Nice.
I'd like to be very soon moving towards a 3D printed cob home.
Yes.
I do have 12 solar panels and a heat pump. We've got rid of our gas central heating and an electric car, and it costs us about 300 euros a month to heat the house, use electricity, heat the water, and run the car.
I'd love to do a workshop on
in winter
electric vehicles.
Well,
it's a passion of mine. That's great.
You're in California.
Thank you so much, you guys, for attending today and helping us out and bringing all this great information to our community. We really appreciate it.
It's been fun, and it's been very interesting.
Thank you to you, Wayne and Kathy, for running the show here, as well as our presenters and our very attentive and wonderful bunch of attendees. It's been great. So we'll do our best to get any unaddressed questions answered. If you registered through Eventbrite, we have your information. If you did not register through Eventbrite and you want the link or some of your questions answered, maybe send Campfire Restoration Project your email and let us know. And I just put a little reminder in the chat just to remind you that we are a nonprofit, and as such, we welcome financial donations to keep our efforts going. And for more information, our website is in the chat, www.campfirerestorationproject.org.
Stacey, this has been recorded. How do we get to see the recording?
Yeah, if we have your information, we'll be sending you a link.
Very good, thank you.
Yeah, and stay tuned for more campfire shenanigans. We're doing plant walks the last Tuesday of every month with Allie Mitter's Night and the folks at TEK Chico. I think the next one is let's see, to the 28th of March.
28th, yeah.
At 5 p.m. at Verbena Fields in Chico. April 29th, we've got an in-person water catchment workshop happening in Paradise, and we have got a seed webinar coming up on May 12th. So stay tuned and join us.
Anybody who's at the CASBA National Conference, I'll see you there.
All right.
In Nevada
So that
City.
is in Nevada City.
Yeah.
Oh, really? When is that?
That sounds like a good time.
Yes.
End of this month.
End of the Casbah? I'll look
Why
that
not?
up. I live
Yes,
in
you
Grass
have to
Valley.
go.
Yeah.
Yep.
All right, thanks everyone. Been
Thank
great.
you very much.
Thank
See you
you.
then.
you.
Bye-bye.
Thank you, Andrew, Mike, and Jesse. Thank you.
Thank you.
Thank you guys.
Bye-bye. Have a nice day.
Bye. Bye-bye.
Bye.